probably going to do it 3 or 4 times or something like that.
You think so?
Yeah, and look, if I get your title wrong, just roll with it.
Yeah, that's fine.
Yeah, we just got to keep it going. Hey, I'm Kelsey Hightower. I've been traveling Europe all week, and I'm in Gothenburg in Spotify, and I have the pleasure of sitting down with Niklas, chief architect at Spotify. I just got back from KubeCon, and Backstage was the talk of the conference. So many talks, lots of organizations wanting to do something like Backstage, but it got me super curious. What is behind Backstage, right? And we talked earlier at lunch about fleet management. You were nice enough to turn your laptop around, and I'm seeing lots of complex architectures, right? The whole Death Star of all the microservices talking to each other. But when I looked at the diagram you showed me, it looked like bacteria underneath the microscope. There was a lot going on there. I want to get into the details.
Absolutely. Welcome and nice to have you here. I'm happy to talk about our architecture and how we think about exposing that to our developers and how we think about managing that complexity.
Wow, Backstage is top of mind for people when they think about Spotify engineering. This is the second time you've all done this. The squad model is something that a lot of people have been pursuing over the years. Mm-hmm. When you think about fleet management, the first thing that comes to mind for me working at a cloud provider, I'm thinking about VMs, bare metal, Kubernetes. Where does Spotify draw the line, and what does fleet management mean to Spotify?
Yes, we really think about it in terms of two sort of layers. So there's the infrastructure, the platform that we provide to our engineers, the thing that we build on top of cloud, the service runtimes, the data pipeline scheduling, whatever it might be. And then on top of that, we have all the components, all the sort of application layer of our architecture where most of our engineers work and provide all the functionality, the playlist services, the search services. And fleet management really operates within that layer and make the maintenance and keeping that part of our software in a healthy state, in an automated and way that reduces the amount of toil for our engineers. And it's an interesting challenge from an architectural perspective to keep the sanity as a company around that and enable the trade-offs that we want, where as the individual engineer, you only have to care about your fairly small component and maybe its dependencies. And in my role, taking a look at that overall architecture and make sure that makes sense as well. And it's been challenging scaling up as a company and trying to maintain both of those properties.
Before we get into the deep technical parts, I think talking about technology without context is like a recipe for disaster.
Yep.
And you mentioned your teams, right? And how your teams work. And I know a lot of the work you all are doing around this area is around making sure there's developer productivity, reducing the toil, all the things companies should be aiming for. But the first time I've heard about Spotify's engineering culture was around the squad model, right? This idea that you would have these teams that would work together, have enough autonomy to get things done. Maybe break down the squad model for people that are unfamiliar, and maybe even give us a taste of how's it evolved since people first heard about it years ago.
Sure. Yeah, it's a good question. So like you said, we published, what was this, 6 years or so ago, published a few blog posts around how we organize ourselves. One thing that is very important to understand, an important caveat, is that we're always iterating on this. So what we published was a snapshot of sort of a canonical model back then. But at every point in time, there's experiments going on around the org. Some org is trying out a different way of organizing ourselves. But the core principle is roughly the same and has been for a very long time. So we have our smallish delivery teams. They might be like 7 to 12 people. That they are the things we call squads. And that's really I would say the atom in our organizational structure. Each squad has their own mission. My go-to example is always like build the best music search in the world. Unfortunately, that's no longer a single squad mission, but I'm going to use that as the simple example. So that means that squad is set up then to execute on that mission, and they own their own product. They own the product strategy and the technical strategy for that, and they decide, again, what components, what do they need to build to be able to get to that mission, and they own and operate that software as well. And then squads, like as in any organization, you need to have some hierarchies and group things. So like they're grouped into a bunch of containers at increasing size up to the largest organizational units that we have within our R&D organization, something we call missions. So there are a few hundred to up to 1,000 people or so at this point.
I always ask people, a good sign that you understand something is to understand when it can't be used.
Mm-hmm.
As Spotify has grown, the complexity, I myself use the app and there's new features, right? Everything from music to audio, books and things like that. Have you kind of seen areas where the squad model just wasn't a good fit for that particular area?
So the squad model, I think it's a trade-off between a number of different things we want to achieve. So one thing that every now and then we stumble on is the ownership and on-call part of it, because a single squad is typically not staffed to be able to be on-call 24/7 for their components. So there's always been some tension there. So we've done a number of experiments with let's try to have ownership across a number of squads and things like that. When it comes down to, again, these trade-offs between having clear missions, having cross-functional teams that can operate fairly autonomously, having strong ownership and the ability to operate our software in production, the trade-off still falls back to this squad concept as the atom in our organization, and then we'll run all types of experiments with how to organize ourselves around that. But that unit has tended to stick around in our org since, at least since I started here 11 or so years ago.
One common question I get around DevOps and sometimes I have this unpopular opinion. Most people say silos are a bad thing. And I counter that with I think silos are okay as long as there's an API between those units. How does the squad model kind of fit into that area? Do they operate like these autonomous islands that communicate through some official channel? How do they operate? Is it more like a silo? Is it collaborative as one would think they should be?
So they are, on the squad level, they're definitely collaborative. If you look at the higher level containers in our organization, things like our missions, we've actually set those up to be fairly siloed. So we have missions that, again, are autonomous around the purpose they have. And that might be building the best consumer experience or building the best creator experience or building the best ads experience. Those are all missions that we have or mission organizations we have, and they all are fairly siloed by design. Once you get down to the squad level, the squads are grouped together in the organization together with other closely related squads, and they typically cooperate very heavily. So with your peer squads, the ones that are close to you in the organization, you tend to have a very close collaboration. I would say that has increased as we've grown as a company because the types of problems we take on have become larger and larger, and there's less problems that fit within a single squad. So that has forced more collaboration. And to your point, has forced us to be more mindful about how we think about things like API separation between teams and how we're more intentional about that.
You put on something that I think I'm going to try to approach this, thinking about this from the person building things, right? Because when you say you have 10,000 services, in my mind, I'm thinking about those individual squads producing those services based on their missions. And ideally between the squads, I can imagine there being just a plethora of APIs and services that are then composed together. So what is the day in life like for someone that's working in a squad? You have a clear mission. I'm going to throw one out, like playlists, right? Yeah. Lots of people use Spotify are happy to say, hey, here's what you've been listening to all year, right? Like you get this roll-up of that. What is the API? What is that mechanism of them saying, what does that look like, the data model? What are they exporting to the rest of the organization?
So two caveats first. So the 10,000, those are several different types of components, not just backend services. Can be data pipelines, can be mobile features, can be websites, whatnot. So that's the 10,000 number is the sort of union of all of those. Good example with the playlist team, because they actually sit in this office just over here. So the playlist team, the way to think about it now, it's an interesting stack to talk about, but they're a full stack team, and they own a set of backend services and front-end libraries, so things that actually runs in our clients. So if you're a typical feature engineer at Spotify, you need to access some playlist functionality. That team will offer APIs for you, both within the client and within our backend and as data sets. So depending on your needs, are you building an ML model, you might need to use the data set that team produces. If you are a backend service that needs to have access to playlist, you will call into their backend API. And if you're a mobile feature, you'll call into the APIs that they provide within the mobile apps, for example. And they then own that entire stack and are staffed to be able to do that.
You talked about teams evolving. Infrastructure evolves.
Yep.
And so, look, it's 2022 as we're talking, but a lot of people want to rewind the clock. So I'm going to ask you to rewind the clock mentally.
Yep.
Go back 3 or 4 years. And I could imagine being one of these squads, writing these services, producing these pipelines. You have this challenge of constant change, deployments, pipelines, all the things that come with that, security. You're all in the cloud. You have all of these things that you're trying to do. What was life like? What kind of toil, what kind of pain was there for those people building services and applications back then, like 4 years ago, before you get to 2022?
Sure. Yeah. So I think there's a few different parts to that. So the one is the infrastructure platform that we provide to our teams. So we have a fairly sizable platform team that provides our internal infrastructure on top of cloud. So they provide a number of tools to make it easier to build software within Spotify. So things like service frameworks, all the runtime environments that we run on, they manage that for our teams. So part of going back a few years and the change up until now has been so we have this pretty strong engineering belief around moving up the stack. So we want to always provide our teams with a higher and higher abstraction level on top of which they can build their software and manage more and more of the commodity aspects of that within the platform. So part of what's happened over, not just, we can go back further than 4 years, it's been like a progression, has been to incrementally take on more and more of that, the work that needs to be done within our feature teams, within our infrastructure platform. So that's one part of it. The other part of it is that within your services or data pipelines or whatnot, there's still a fair amount of stuff that you need to maintain. Like you said, security, keeping your dependencies or libraries that you use up to date, staying on the right Java version or Python version or whatever you happen to use. All of those things. So over the last 2 years, we've started to take that on with something we call fleet management, where we really want to simplify and remove a lot of toil for that piece of the development for our engineers.
You mentioned a couple things. Right now, platform engineering is a really hot topic. Mm-hmm. I think it's hot because people are trying to understand what it means. And I think you've gotten into a few things here. So fleet management, when I hear fleet management, especially in the context of platform teams, the thing that comes to mind for a lot of people is, a bunch of virtual machines or a bunch of Kubernetes clusters. But that line tends to stop at the infrastructure layer. And then there's this kind of ambiguous handoff piece.
Yep.
When you say platform team and when you say fleet, what are you talking about?
Yes, we think about it in a slightly different way, I think. So we have our infrastructure platform that we provide to our teams, things like Kubernetes or our observability platform or whatnot. So that's one part of it. But then, as I mentioned, over the last 2 years, we've also tried to make the application layer on top of that more easy for our teams to maintain. And going back to what we talked about earlier around having this large number of fairly small components, that means that if we go back a few years again, the way we would do things like we need to move from Java 8 to Java 11 or from Python 2 to Python 3, or we need to deprecate this library that we don't want to use anymore, or we need to fix a security vulnerability. All of those things, they would happen through migrations. So we would tell our teams, for your, let's say, backend services, these are the actions you need to do. But obviously, as the number of components scale, that manual process becomes more and more painful. So the time to do one of those migrations could be months or years. And it was a lot of really boring but plenty of work for our teams. So when we talk about fleet management, going back to your question, what we're saying is we really want to be able to, from our infrastructure team's point of view, take more of that responsibility for you. Instead of you managing, always staying on top of what libraries you're using, we're going to do that for you. Or instead of you having to patch the security vulnerability, we're going to do that for you. You won't even notice that we do it. You're not going to be in the loop for those changes, and we're going to automate it. And this is, we can talk more about this if you're interested, but this is, for us, was also a big cultural change, because we have these components that we talked about. We have a very strong notion of ownership for those. You build, own, and operate your own software at Spotify. So that means that you're the one that's going to be waking up in the middle of the night when that thing breaks. At the same time, with fleet management, we're saying we're going to start making changes to those. You're not going to be in the loop. We're going to merge those changes without any manual review from the owner, and we're going to deploy them automatically. So we perceived this as a big cultural shift at Spotify, or it was a big cultural shift at Spotify as well. So that's a interesting part of this effort, has been to prepare for that.
So you all have moved the concept of fleet management up the stack.
Mm-hmm. Very much so.
And so there's some assumptions then at the base layer. And I'm going to do this because I know people that are watching this nuance is probably going to be very critical for them. What are the assumptions being made here? Is it the assumption that we're in the cloud, we have automation for spinning up these Kubernetes clusters, we have a clear contract, right? And in my mind, I'm thinking, are developers just writing a bunch of YAML files, Helm charts? How are they communicating what their applications need from the infrastructure? Or is that layer also abstracted away into this fleet application layer?
So yes, you're right. The components define what they need from the infrastructure. So if we take the example with backend services, they will run in Kubernetes. They will have the usual Kubernetes YAML files to say, I need these resources, like CPU or memory resources and whatnot. We also use the way we declare the cloud resources that we need. So, service accounts, databases, blob storage buckets and whatnot are also all declared in Kubernetes manifests. So that means within your component, you have defined what you need from the infrastructure. And that lives with your code in Git. And then with fleet management, what we do is that we go in and actually manage those things for you. So to take a very concrete example, looking at something like dependency management. So one of the first things that we've taken on with fleet management is that we will manage all the library versions that you use for you. So to take an example, most of our backend is written in Java. It's built with Maven. So what we do is that we have centralized all the dependency versions into a centralized manifest with Maven that's called a BOM, so that we have one of those central BOMs. It defines all the versions for the most common libraries we use. And with fleet management, we're now managing what version of that BOM that you use within your service. And we update that daily across our fleet. So every day we have basically a bot that goes around, upgrades that BOM across all our 2,500 or so backend services, and merge and deploy those changes into production. So that means that our entire fleet of backend services gets redeployed every day with the latest version of the libraries that we want to use. That's just one example, one use case for fleet management, but it's a pretty easy one to reason about.
When I think about like fleets, fleets of planes flying together,
Mm-hmm.
is this a monorepo? Like, how do you deal with it? Because, there's one approach where I can imagine every squad having one Git repository per app.
Yep.
Or I can also imagine a world where there's a big monorepo for the entirety of all of Spotify to make this easier. Maybe give people a little insight of like, where's the code stored? And how do these tools interoperate with those code repositories?
It's a great question. And one, when we set out to do this, that we thought of as a very critical and maybe like non-reversible type of decision. It turns out that that's maybe not the case, but let me reason through it. So in practice, we do not use a monorepo for most of our components today. We do use some very large repositories for our clients, so things like our mobile apps and desktop apps. But our backend services and data pipelines and websites and whatnot are mostly stored in fairly small repositories, one or maybe a few components in the same repository. And when we started thinking about, or started realizing that we need to make this shift towards thinking about our software in terms of the entire fleet, one of the first things we need to figure out is, do we move to a monorepository? And Google, for example, is a great example of a company that did that very early and has been very successful and leveraged that model. We also get a lot of benefits from not using a monorepository. There's a lot of investments that we don't need to make into making a scalable Git or a scalable CI. So we realized that a lot of the tooling that we were going to need for fleet management, we're actually going to need also in a world where we do a monorepository setup. I can talk more about that later. So what we actually decided to do was to move the decision if we want to move to a monorepo to a future date. That's always a sort of continuous evaluation we do on when we want to make that switch. So currently we are operating on top of thousands of repositories. And that means that when we do this type of dependency managed updates or any change to the fleet, that needs to operate across many, many repositories. But again, and I actually know part of this from speaking to a lot of Google engineers, for example, on this topic, turns out that the way you need to manage those large-scale changes is actually pretty similar in a monorepository. If you make a change to thousands of components, you can't really do that in an atomic commit because you're going to be waiting on the last reviewer of those changes. Or you're going to have a very large coordinated deployment for you. So you're going to need a similar set of tools. And I know that Google has a lot of those tools internally to manage these types of changes. So I think we've ended up with, we could talk more about the type of infrastructure that we built, but I think we ended up with roughly the same infrastructure as we would have done if we would have been in the monorepo. So the decision for us, if we want to be in many smaller repositories or one big monorepo, actually comes down to a different set of parameters. Like how do we want teams to author changes to like fleetwide changes? How do we want to manage things like code consistency and so on? So it is an ongoing discussion if we want to change to that model, but it's actually turned out to be a fairly small parameters in terms of how we implemented fleet management.
And it totally makes sense because even in Google, when we have the monorepo, you think about code and this directory structure as a namespace in many ways. And using a URL or one repository gives you the same namespace semantics. And of course, your tooling can just account for that at the various levels. We're going to keep moving up the stack, right? So it sounds like developers have a clear contract between the infrastructure, whether it's Kubernetes files or manifests. They have joint dependencies being managed. So you now have maybe kind of a blessed set of third-party dependencies that you can depend on being managed by this central team. I would imagine also as we go up the stack before we get into, how these things are deployed, any frameworks for communication. We know things like gRPC are super popular. What does it look like at that protocol layer as these fleets communicate with each other?
Yeah, so we're actually right in the middle of moving to gRPC. So many years ago, for reasons that are maybe interesting but pretty historical at this point, we ended up developing our own service-to-service protocol called Hermes. We had early on had a lot of scalability challenge with the way we used Python and HTTP at the time. So we ended up developing this lightweight queuing-based protocol. Hermes was great, but it was also very proprietary, and we were the only ones using it, and it made it really hard to reuse a lot of the great infrastructure that is available now. So we are, like I said, in the process of switching to gRPC. It's a very large effort because, again, you've seen that dependency graph. You can imagine like every vertices in that graph is one or more interactions over some protocol. So there's many, many thousands of those interactions to replace. So I think we're going to be in that transition for some time. But yeah, so we're trying to switch to gRPC. I don't actually know exactly what the percentage of completeness.
Yeah, that's going to be an interesting one because I think it aligns with this model around here's an explicit set of dependencies that are managed for you. And I think protocol buffers allows each of these squads and teams and their missions to be serialized in some ways into protocol buffers, right? This is how you interact with us. And it sounds like you all are writing modular code, right? So when I looked at that diagram of those 10,000 components, which are a mix of back-end jobs, ML jobs, I would imagine, the code is modular. There's probably lots of code reuse. Some people would say, like, why not just like optimize for combining as many of them as possible into like a huge monolith and deploying it that way? Can you speak about like why do you also follow up with a deployment model that is, I'm going to say, hyper modular, where you end up with that many services being deployed?
I think the big value comes down to what we talked about earlier, and that's teams' abilities to deploy and operate their software in runtime without having any strong dependencies on each other. So if you and I you own some backend service, I own some backend service, I need to call into yours. That means that we have a dependency. We have a protocol dependency or an API dependency. But as long as we deploy our things independently, we do not have any dependencies on I'm in a code freeze because we're at an offsite. So like those types of coordination, we don't need to do. So it means that we can deploy thousands of times per day without teams doing any coordination between themselves at all. That is an incredibly powerful mechanism, in particular once you get to scale and once you have actually like the flip side of looking at that complex dependency graph is that you really want the nodes in that dependency graph to be as independent from an operational perspective as possible. But it is a trade-off. Like you could definitely get some benefits from co-deploying those as monoliths instead. And we have done that from time to time. And it's been interesting because every time we've done it, as we've scaled up as a company, the things that seemingly belong very closely together at some point in time, as we scale up, gets more and more painful to have them together. And we have continuously had to decouple our monoliths over time because what was owned by a single squad is now owned across 15 different squads because that org has scaled up because the needs are much bigger at scale. Even in those like more monolithic deployment scenarios, we've still had like fairly fine-grained components. We have been able to tease them apart. So long story short, I think we're actually pretty strongly convinced that this small component model is the one that works best for us. And when we have broken that assumption, it's been painful for us. So we've learned that lesson the hard way.
And it seems to make the decision-making process of the teams themselves, right? So when a team decides that they want to move forward with gRPC, they can keep both versions online, and any team ready to interface with gRPC with that team can make that decision independently of bundling
That's exactly
this
right.
new library. So I think we now have a good understanding of what a fleet unit is. There's this big concept around fleet management. And I think we're starting to get below the surface of something like Backstage. And we're going to work our way up there. But I can imagine the toil that comes with this, right? So I can imagine being in one of these squads and we're out here deploying, right? Everything, every new idea, every experiment. And so I'm thinking about, what are we doing about observability? What are we doing about logging? How do I know what's going on with something that I have a loose dependency on over the wire? How do you deal with that kind of toil in terms of a team being able to debug, monitor, and I'm going to throw another one at you, adhering to security policies, right? How do you think about those things?
So a lot of that we try to build into our infrastructure platform. So if we keep to the example of backend services, within your service framework or the service framework we use, you get a lot of these things for free. So you get a baseline of observability. What's your request per second? What's your errors per second? Like all of those comes out of the box from the platform we provide. Same things with logging. Same with a large part of security policies, for example. All of those are provided for you. And as an engineer, you operate on top of that platform. And you can extend it. Like you can, if there are things from an observability point of view, more application level metrics, you can of course extend and like add to that platform. But you always get that baseline out of the box for you.
This golden path, it sounds like there's this golden path pattern.
Yep.
Where does it start, right? Because a lot of times when I think about, let's talk about the Kubernetes model, right? There's a YAML file where you can specify things like memory, volume mounts, but then there's the other layer, which is like, am I using Prometheus or not? What are my metrics endpoints? Where should the metrics go? Where's that defined? Because there's a couple of approaches. One is the developer implements some contract in their own. They import their own version of Prometheus, and you hope they do things the same way as everyone else. And there's this other approach where there's like an SDK, if you will, that if you just import the Spotify logging library, you're good to go.
Yep.
Which route did y'all lean into?
So it's much more the latter, I would say. So again, monitoring is a good example. We do not want to expose if we use Prometheus, or we actually don't use Prometheus behind the scenes, as the engineer building a backend service or a data pipeline or a website. What you're exposed to is for observability some API for registering and collecting your metrics. So that might be something like OpenTelemetry or an API like that. And then whatever sits behind that, whatever the implementation of our observability stack is, that's part of the platform. So as an engineer building a typical backend service, you shouldn't need to care about that. Of course, in the end, there's some monitoring tool that you're going to have to use to actually watch your graphs and whatnot. But the stuff that happens in between that should be abstracted for you. You can interact with that if you want to, but I would say that's a fairly uncommon edge case.
The one thing that I'm hearing this whole time that I think companies struggle with, as a company evolves and changes over time, where does the learning go? Some people put it in a documentation. Some people have a couple of go-to people. Maybe in each of the squads, there's just a person who knows what to do. But it sounds like you're doing a wonderful job of serializing your engineering culture into these libraries, right? So if you make this decision that we're going to log a certain way, we're going to do metrics a certain way, that is now available as a library, not a doc that you have to read and hope that you get it right in your own code implementation. Would that be a fair assessment that you tend to serialize what you learn in a rapid fashion, or is there a lot more time and space between those two things?
I think there's definitely some time and space. So I would say, as any company goes in my experience, there's some part that you need to learn the hard way. So some of that might be how to build a resilient service, things like that. That is part of what you learn as an engineer as you mature at Spotify. There's some part that we have codified into documents. So you mentioned golden path, for example, before. So that's something that we use very heavily. So there's a golden path for every component type we have. So how do you build a data pipeline? How do you build a website? How do you build a backend service? And it's essentially a tutorial that you go through. Like, this is the canonical way of doing that at Spotify, including how to set up your environment, how to bootstrap your code, how to do your first deploy, like all of those steps. And then the things that are most mature are codified into libraries and into the platform. And I think things progress through that sort of life cycle, and there's always parts of our stack that are in those different stages. So some aspects, some of the examples we talked through now are very mature and they're part of the platform. They're well abstracted away from the engineer. And a lot of stuff that is earlier in its life cycle is less mature and less like abstracted for you. So I think there's always some messiness in that. So everything is far from perfect for sure.
When I think about other industries that have large fleet management problems, you think like airlines, right? Depending on when that plane was bought, it may have the new interior, right? The new fast Wi-Fi. But there are other planes that are still good.
Yep.
And the seats are a little older, right? You have to use your laptop because there is no screen in the back of that headrest. How do you all think about the natural flow that change tends to happen over time? My guess is all 10,000 of those components don't get the latest and greatest in real time. How do you think about fleet management over time?
It's a great question. So there are parts of those components that we actually want every component to get all the time. So again, things like library versions is something that we want, even if you're a relatively old component.
Log4j.
Log4j is a great example. So back in November, we had this big Log4j security vulnerability. It was the canonical example of the type of problem that we want to be able to solve with fleet management. And we were able to roll out the fix, again, across all our backend services within, I think, 6 hours or so. And that's exactly the thing we want to do. So even if your backend service is old or has been around for a long time, we still want it to have the ability to get those version upgrades every day in an automated way without any toil for you as developer. And that's challenging, to your point. Like a big part of realizing this notion of fleet management was to get every component up to a base level. Like, are you now at a level where you have the library versions you use is at a sufficiently modern version that we can start automatically managing it for you? Do you have sufficient test automation so we can make those changes and deploy your component without any human verifying them? Do you have the observability so if things goes wrong, we can actually detect that during deployment? Like all of those things were, to your point, there was a lot of variance in the fleet, and we needed to move everything up to a certain minimum standard, let's say, or minimum threshold before we felt confident in like claiming that it's now managed for us.
And I can say as an engineer, the logging module is probably not something that I have a lot of attachment to, right? Like, I need to log. We use Log4j. I am happy for your team to take that over. You own it. But then there's other areas that are a little bit more opinionated, right? If your team were to step in and take over, I mean, going from HTTP or a custom protocol to gRPC could be one of those things where people have attachment to. There's two parts to this. One is, how do you ensure, like for Log4j, what happens if something breaks? Who's responsible for testing? Your team initiates this large-scale change, but then it breaks something. Are we now collaborating on this fix, or is this something that your team is going to try to see through to the end?
Yeah, it's a great question, and it's complex. So the way we think about it is that there's an owning team for the change itself. So they need to make sure that fleet-wide change is safe to roll out, and they have test frameworks and similar that they can actually do that, so they can test that fleet-wide change. But then I might own a very particular backend service that happens to break anyhow, even though we've potentially tested that change on hundreds of backend services. Mine might be the odd one out that fails anyhow. So what we define that is that then that's you as the component owner, you need to make sure that you have sufficient test coverage to find if your service or pipeline or whatever actually breaks during one of those changes or during deployment. So one of those like baseline things that we put in place was to make sure we had good integration testing, so that once we've updated all those library versions or made some other change to your component, we're actually confident enough that it still works so that we can deploy it automatically. So it's a big part of that shift.
Now, the other part of that is the consensus part. A group of people who have done a great job managing things like Log4j come around and say, it's time for gRPC.
Mm-hmm.
And I can imagine the people, number one, who built the other thing are like, hey, I'm not so sure about this. How do you get to the consensus building component before this becomes a standard?
Right. Yeah. So maybe let me take one step back first. So I've been talking now about certain types of changes that we want and are able to automate. There are definitely changes that we're not able to do that with. So the transition from Hermes, our proprietary protocol, to gRPC is one of those changes, because it actually changes API semantics, and Hermes is much more protocol inspired by HTTP and REST. So like thinks about things in resources and whatnot. gRPC is an RPC framework and thinks about things as RPC calls. So that means that there are fundamental changes in how to think about building APIs for those two protocols. So that's a good example of a change that we have not opted to manage through a fleet management type of mechanism. Going back to your question, though, that's the potentially the hardest question of being a large company is you want to make these large architectural changes, and you have engineers with a lot of opinions, good opinions on those changes. So it requires a lot of discussion and feedback. So one of the things that we make heavy use of is RFCs internally. So before making one of these large changes, it will be written down in an RFC. It will collect a lot of feedback from engineers to allow teams to give feedback on a change like that. So we try to use that to be collaborative and act on that feedback in a productive way, and to gather high quality feedback to actually catch as many edge cases before we make the change as possible. But a change like the Hermes to gRPC is multi-year, iterative, like it's going to take several RFCs to get there. And for that change, we've also changed our strategy on multiple occasions on how we actually get there.
You know, I'm glad you called out the multi-year expert of because I think a lot of people get confused about how long it takes to evolve, fleets. I used that airline analogy earlier. If you're someone like Airbus or Boeing and you want to produce a new airplane, mm-hmm. you have to make sure that it actually will integrate well with the existing fleet. And you probably want input from the people who operate airlines on what that plane should actually look like, because the customer base could have changed. The way they want to use it may have changed. And one thing I think around progress is, so we talked a lot about building these APIs, how we ship and build components and upgrade those components. Mm-hmm. But when you step back as a developer, you have to register these APIs, right? You have to define paths. You have to talk about how things get consumed. You have to define policies about who can consume your API and not. Yep. And so you start to go a little higher into the stack. And if I'm understanding things correctly, like what gives birth to something like Backstage, right? Maybe for people that are not familiar with Backstage, as you move up the stack and now you have this more of a, feels like a more of a UI way to define things outside of that context that we talked about earlier. So far, everything was done in that Git repository. Mm-hmm. And now you got this UI. What gives birth to that? And what type of things do people do in that UI? And what problems is it trying to solve?
Yeah, it's a great question. So to maybe explain things from principles here in a way. So we want as much as possible to live in source control. So again, we talked about the declarations you need of what things you need from the platform. You want all of that to be in Git. But even on top of that, what we found, and this was now, I think we started this journey probably 10 years ago at this point, with the precursors to what is now Backstage. We started realizing that there's a lot of tools. There's a very fragmented set of tools for engineers. So there's one tool to look at whatever your runtime environment is. There's one tool to manage your capacity, one tool to manage your observability and whatnot. And we saw through user research and talking to our developers that this was like this fragmentation for them caused a lot of context switching and had a very high bar to be able to contribute at Spotify. So what we set out to do, and it started with a much less grandiose plan than what Backstage is today, was to have a single pane of glass for developers. And that thing just started as this registry of our components. We talked about the 10,000 components before. We didn't have 10,000 components back then, but we still had lots of them. And we needed some way to have a central place to register those. So that if I'm on call and I'm dependent on your service and your service is seemingly broken, I need to figure out who owns that component. Just answer those basic questions. That was where it started. What we realized was once we had that registry of components, that was actually an excellent place to inject other management aspects of that. So if I want to be able to go in and manage how much capacity I have for a specific component, I could do that within the context of that component in Backstage. So pretty quickly we shifted, again, this was before it was called Backstage, but we shifted that to be plugin oriented. So you had this registry of all your software, and for each component within your software, we now had essentially plug-in points for our infrastructure teams to start plugging in all the different aspects of being able to manage your software. So again, things like capacity, seeing what's deployed, seeing your ongoing incidents, all of those things slowly over time moved into being within Backstage. And actually now, for us, in reality, provides the single pane of glass. So as a developer at Spotify, you interact with your source code and your local development environment and Backstage, essentially. It's taken a long time to get there and a lot of iteration, but it's actually become a very powerful abstraction for us.
There's one group in particular I want to get inspiration from that. I used to work in a knock, right? Like this is the night shift tech job. And you look at this dashboard of all of these services. I worked at an ISP, so cell towers would go down, and you needed enough context on that screen to make a decision. Restart it.
Yep.
Call someone. Is it really a problem, or should you just keep an eye on it? And as that organization grew, they started to put the right set of capabilities into this thing. And I think a lot of organizations have maybe the genesis of a Backstage. Maybe they can't express it in the terms that you have. But I think a lot of companies understand the fundamental need of taking the task of managing software, which can be very different than the task of revolved around building and constructing software, and centralizing those somewhere where my guess is it democratizes that for the entire team. If you're on call, you may be unaware of a service that you don't really work on. My guess is Backstage just gives you this head start of resolving common problems without having to dig through. I think some people have a lot of this functionality via links in a Confluence wiki.
Right.
I click here if you want the logs.
Yep.
Click here if you want to know how much memory you should have on this service. And do you think that that's how Backstage kind of evolved? And if so, where does it go from here?
So another aspect to that is that different services, let's say again, will look the same in Backstage. So your service and my service will use the same UI in Backstage. And that means that if I'm on call or whatever, and I need to figure out what's the state of your service, I can go into your service in Backstage. I have full access to it, or at least read-only access. And I can see everything about what's going on with it. And it looks exactly like it does for my own services. So it lowers the threshold. And again, when you have hundreds of teams and thousands of components, having that level of UX consistency becomes very valuable. So then the question, to your point of like, where do we take Backstage from here? So I think we took the first step in that journey a few years ago when we open sourced Backstage and donated it to CNCF. And our goals with that is really to build a really healthy ecosystem around Backstage. For Spotify, we've been able to build the plugins the sort of basic plugins that we need. So I think we have 180 or whatever internal plugins within Backstage. But we think this is a powerful mechanism that we can actually use and leverage outside of the immediate needs that Spotify has. To your point, the abstraction of having a developer portal, having this one pane of glass, seems to be relevant for most companies, at least most scale-up companies. So instead of every company building that portal on their own and building their own plugins and whatnot, how about we figure out one shared framework in which we all can target our plugins for, and that's Backstage, or we hope to be Backstage. And then we can all build plugins. And some of those we might open source and provide as sort of common foundation for everyone to be able to use. If you're a cloud provider, you can provide plugins for your products into Backstage. If you're an ISV, you can provide it for whatever software you provide. Or if you're an end user company, you can build and provide your own plugins as well for your own particular needs. Exactly what Spotify has done. So that's the sort of belief we have around Backstage. It's a long journey to actually get to that point where it's like that foundation, but we think at least we have the fundamentals right, it seems. And now we need to build a functional ecosystem around it.
At Google, years back, we had this document that went around that Google needs to get off of our own digital island, right? Before we've open sourced things like Bazel and Blaze, Stubby to gRPC, things like Golang, there was this idea that as much as we appreciated our custom landscape of technology, hiring someone from the outside world, the ramp up period is amazing of how long it takes for them to understand all of that. How much of avoiding being on your own digital island led into the idea of open sourcing Backstage?
I would say a big part of that was exactly that need. We're not afraid to build our own proprietary software. We talked about Hermes, we talked about early Backstage and whatnot, and we have many, many other of those examples. But just like you say, that puts us at risk as a company for many reasons. Hiring is one of those. Just maintaining that software forever is one of those. And by open sourcing and providing that fundamentals, we can also leverage for Backstage plugins that other companies provide to that ecosystem. I think similar, it is funny that you mentioned the examples you mentioned from Google. Like I think all of those has been large transitions within Google as well. I think Google is still not fully on gRPC or fully on Kubernetes or whatnot. So I think we're seeing the same. Like we are making the transition to fully use open source Backstage, to be able to use those external plugins and whatnot. So it's a bit of a transition, takes some time, but that's exactly where we want to end up.
You're the VP of engineering at Spotify, and there's a lot of executive leadership roles that hear everything we talked about so far, and they have this other challenge. How do they sum this up from a business perspective, right? We get and can respect the time you can save engineers, but there's also a cost, an ongoing investment to the platforms underneath to get that and sustain that agility. How do you think about justifying these continuous investments into things like Backstage? Because you're no longer now maintaining this for Spotify. You're maintaining this for everyone else as well that chooses to use it. So how do you think about the business value and that ongoing investment?
So I think there are two interesting examples that we talked about here. We can talk about Backstage and we can talk about fleet management. And I think we reason about those slightly differently. So let me talk through those two. So Backstage, if I were an adopter of Backstage, so that's, I think, the most relevant persona here. The way I would think about it is, how do I maximize my developers' productivity and happiness? Rather than, again, having this very fragmented ecosystem that we know will cause a lot of toil for engineers, can I remove that by having this single pane of glass? Can I leverage that ecosystem we've been talking about? So if I'm on AWS, I can get the AWS plugin for Backstage, which manage my EC2 or whatever capacity. Same thing on GCP. So that's the way I would think about something like Backstage from a pure developer productivity tool. With fleet management, the end goal is sort of the same, but we have a different approach there. For that, we purely, or with a strong focus, we want to remove a lot of toil for engineers. Things they do today, again, managing all of these, like keeping yourself up to date, managing security vulnerabilities, managing reliability vulnerabilities. Can we remove much of that and actually automate that away for you? And at Spotify scale, it turns out that you can do that. You can actually save a lot of time for yourself and really boring work for engineers. At Spotify, we now estimate that we have saved around 200 headcounts just by automating away things. And that means that we now have 200 engineers that can do a lot more productive and interesting work at Spotify rather than doing all of this toil.
I'm going to pull on that thread around calculating the cost savings, right? A lot of times people will target a reduction in infrastructure spend. But one thing that goes missed often, and in Google, we call this SWE hours, software engineering hours. Yes. When you do that calculation, is it easy for other people to understand? And is it respected that, hey, we have people that are doing something else? So maybe there isn't a reduction in headcount. Maybe there isn't an automatic reduction in cloud spend, because my guess is when you automate things, people tend to do even more faster. How much is this like having our people work on something else calculated and understood throughout the organization?
So I wouldn't say that we're super mature around how we're able to do those estimates, like doing them with high precision. But for something like fleet management, where we can actually measure the toil that our developers do fairly well, we can see what amount of code changes goes towards things that we can automate, or what amount of operational work goes towards things that we can automate. So for something like fleet management, we've actually been able to estimate that with fairly high precision. Still, like, there's definitely variance on those numbers, but that is certainly not true for every change we make. So there's still a lot of work I think we need to do to improve how we reason about those savings as well. And it's certainly, to your point, for us, when we want to remove that toil, it's not around making it's not to reduce the amount of developers we have. It's to make the life as a developer at Spotify feel as productive and enjoyable as possible. That's the purpose of this work.
We talked a lot about fleet management. And one thing I think is probably helpful to give a little bit more insight into who is doing the fleet management. You know, it's common in the industry, and maybe it goes a little bit back to the silo discussion we had a little earlier. There is a belief that all teams should carry this burden, if you will, of identifying these opportunities around fleet management. Mm-hmm. And it sounds like, and I could be wrong here, and it'd be good to get your clarification, it sounds like fleet management is done by more of a central team in an attempt to remove that from all the other squads that are really focused on their independent missions that may not be centered in fleet management. How is that split? How is that area of responsibility? And how do they interact with each other?
So the way we think about it is that we want to enable every team at Spotify to do these types of fleet-wide changes. Naturally, I think the early use cases that we've seen are primarily driven out of our infrastructure teams. So the teams that provide infrastructure for other teams. But it turns out that there are teams within Spotify that provide business platforms, let's say, to other teams. So we talked about the playlist team earlier. It's a great example. Turns out that the playlist team have hundreds of teams that use their APIs today. So if you look at the Spotify ecosystem from the perspective of the playlist team, they actually have a fleet of consumers of their APIs that they need to manage as well. So if they want to make a change to their APIs, they can't just make that in a non-backwards compatible way, because it's going to affect 300 other teams. So they need to think about their consumers and how to evolve the playlist platform at Spotify in a fleet-first way as well. And they actually do. So to take a very easy example, they have a library that they release on essentially like one aspect of how to interact with the playlist platform. They manage that through fleet management today. So we want to be able to make every team able to do it. It's probably not going to be every team at Spotify, because not every team operates those types of platforms. But the teams that do, we want them to be able to use fleet management in an easy and productive way. We're not fully there yet. There's sharp edges in the platform today and things that we want to improve. But generally speaking, we have a lot of teams that are able to make these fleet-wide changes today.
When you describe that interaction between the playlist team and other teams, the thing that immediately jumped into my head was a Venn diagram, right? I can imagine earlier, if I was thinking of fleet as all of Spotify, mm-hmm. I can imagine teams like the playlist team having almost a subset of the fleet
Yep.
that they treat in this way of, we have a new library, we need the fleet to move in that direction. And the fleet could just be the consumers of that library and maybe not thinking too much about everything else that's outside of the domain. And my guess is that diagram gets much bigger for the infrastructure team managing something like Log4j, but that may not apply to someone doing something on iOS, if you will, right? And so is that a way of thinking about that fleet now have like sub-fleets in them that independent teams can actually do fleet-like activities too?
That's exactly right. And I would say it's very rare, or I don't think we've had a change, maybe we have, that actually goes to the entire fleet. Like it's almost always some subset you target. And part of that, then, of course, you need to be able to figure out what subset of the fleet do I need to target. If I'm the playlist team, who are my consumers? If I'm the team managing a Log4j type of security vulnerability, they need to be able to figure out which components in the fleet are actually using Log4j. So there's one aspect to this is what we call a fleet insights, like collecting, instrumenting, and be able to do analysis of your fleet as well. This is very important for this.
I think we are at a point where I think fleet now, my understanding is it's just continuing to move up the stack.
Mm-hmm.
And so when a company decides to go in this direction, sometimes you have a 5-year roadmap in mind. There is something that the fleet's going to, or the concept of fleet management that's going to allow you to do something you couldn't do before. Where are you going with this?
So for us, there's a few parts to that. One is internally, we want to be able to take on more and more complex changes. So the things that we've done today, we've done some 70-ish fleet-wide changes today. They're fairly simple, but we want to make more and more advanced code refactorings or be able to manage more complex infrastructure changes in the same way. Part of that is the authoring piece, like how do you author change to source code in a way that is safe and verifiable. And part of that is just for ourselves building confidence in our ability to make these changes in a safe and reliable way. So I would say over the next year or two, I would expect most of our iteration to be around that, like take on more use cases and incrementally more advanced use cases. And we also want to make the authoring and sort of rollout management easier for our teams. Again, going back to what we talked about before, enabling more teams to make these types of changes in a way that they feel that they're safe when they do that. So that's one part of it. We're also trying to figure out, do we want to externalize some of this stuff? We talked about Backstage and plugins. Some of the infrastructure that we built for fleet management is certainly not unique, doesn't need to be unique to Spotify. So we want to figure out what parts would make sense to open source or potentially commercialize over the next few years as well.
We're going to wrap up. Fleets are often built and maintained to take companies or people to destinations they couldn't get on by themselves. Spotify can leverage this fleet to do what in closing?
Make our developers feel more productive and be happier at Spotify and keep our fleet in a healthy and maintainable state at all times.
Awesome. Thank you, Niklas.
Thanks for having me.